Hi everybody, this video is going to talk about how to graph functions, and we're going to look at a couple different types here. We're going to look at discrete graphs, and we're also going to look at continuous graphs and how we know which type we're supposed to be graphing for a particular problem. So you can see here the directions say we want to graph the given function using the given domain by making a table and then plotting those points. Okay, so here's what you really have to get. This is the function we're graphing for a particular set of x values. So remember, domain is x. We are graphing this function only for these particular x values. And what that means is when I go ahead and I find all my ordered pairs and I plot them, because I want this specific domain, I'm not going to connect my points. This is going to be a discrete graph. It's going to be just the points plotted, unconnected. Because once I start connecting those points together, my domain starts to grow. Okay, and I want to just keep these particular x values. So we're going to have a discrete graph. And when we're using our table, we're going to use only the given x values. We're not going to use any x values other than the ones that were given to us. And to use these x values, we're going to take them and we're going to copy them into the x column of our table. So here's the idea. Okay, in the previous video, we were evaluating functions. We were saying, hey, for this x value, this function has a y value of this. So that's really what we want to do here. We want to find the y values that pair up with these given x values so that we can plot those ordered pairs and get the graph as a result. So if I want to know the y value that matches up with -2, I just need to plug -2 into my original function and I can figure out what that would be. So we're going to do this off to the side. Our function is x squared minus 3. So let's plug in -2. So -2 squared minus 3 would give us 4 minus 3, which is 1. Okay, let's plug in -1. -1 squared minus 3. So that would give us a positive 1 minus 3, which is -2. We're going to plug in 0. So 0 squared minus 3, that would give us 0 minus 3, which is -3. Plug in 1. 1 squared is 1, so we get 1 minus 3, which is -2 again. We'll plug into, so we get 4 minus 3, which is a positive 1. Now remember, each row in my table here represents an ordered pair. So we can take each ordered pair here and plot it, and we're done. That's our graph. So we have -2, 1. We have -1, -2. We have 0, -3. 1, -2. And 2, 1. And remember, we're leaving this graph discrete. We are not connecting the points because if I connect the points, my domain will grow. And I want my domain to remain these 5 values that were given to me. The -2, -1, 0, 1, and 2. So this would be it for the problem. Okay, let's look at another example. Okay, so again, graph the function for the given domain by making a table and plotting the points. So again, we're given a specific domain here. So our graph again will be discrete. And we're only going to use the x values that were given to us, so let's copy those x values down. Now, I know that I'm missing that last row, but that's okay. It's just the size of the table. I don't need to fill it. I need to fill it, okay? I only am using those 4 x values for this problem. Now, here's the catch. This is my function. Okay, 2 issues. One, it's not solved for y, and we're not using function notation. So here's what we need to do before we do anything else. We need to solve this equation for y, meaning we need to get y by itself. Okay, if I want to get y by itself, I need to cancel out this minus 2x by adding 2x to each side. That gives me y equals 2x plus 6, and then I can change it to function notation by writing it as f of x equals 2x plus 6. So now I'm set up and ready to go I'm ready to take these x values and substitute them in and evaluate the function at those points. Okay, so let's plug in -5. So we have 2 times -5 plus 6, which will give us -10 plus 6, which is -4. Okay, then we can plug in -3. 2 times -3 plus 6. Okay, well, 2 times -3 is -6. And if I add 6 to that, that gives me 0. Let's plug in -1. So 2 times -1 plus 6. 2 times -1 is -2. If I add 6 to that, I get +4. And our last one here, we're plugging in 0. Remember, anything times 0 is 0. And 0 plus 6 gives us 6. So let's plot our points, and since it's discrete, that'll be it. We'll plot our points and we'll be done. So that's -5, -4, -3, 0, -1, 4, 6. So there's our graph with the given domain. So let's look at one where we don't have a given domain. Well, we have a given domain, but it's not specific numbers. The domain is all real numbers. And when you have a domain of all real numbers, something's going to change here. Okay, the first thing that's going to change is your graph is going to be continuous now, meaning we're going to connect our points. The second thing that changes is you have to choose your own x values. Okay, I didn't give you any that you had to specifically use. Okay, the domain is all real numbers, so it could be anything. Okay, but let's be careful here. Our x-axis goes from -6 to +6, so we don't want to pick anything outside of that. Okay, and we want to be strategic about picking which x values we want to use, because if I pick just a few points on the left side or just a few points on the right side, I might not get the full image, the full graph, and I'm not going to end up getting a good idea about what this function looks like as a graph. So we want to make sure we're picking points in the middle, on the left side, and the right side of our coordinate plane. And I usually like to pick these ones. I like to pick 0 because it's right in the middle, and then I pick 2 points on the left, 2 points on the right, and that kind of ensures that I'm going to get a better full picture of my graph. Okay? But at this point, the only thing that's going to be different than the previous ones is after we plot our points, we're connecting. So let's go ahead and plug these into our function. It was all set up and ready to go for us, so we're going to plug in -2, right? -2 squared plus 1, so we get 4 plus 1, which is 5. -1 squared plus 1, we get 1 plus 1, which is 2. 0 squared plus 1 gives us 1. Okay, plug in 1, so will give us 1, 2. Plug in 2. We get 4 plus 1, which is 5. So now we can plot our points and connect. And here it is. Okay, so this one has a curve to it. Later on in the year, you'll learn that these are called parabolas and quadratic equation because of this x squared right here. But that's down the road. For now, you just need to know that you're connecting your points because it's a continuous graph, because we have a domain of all real numbers. Let's look at one more where we have a domain of all real numbers. Oh, just kidding. That was the last one on here. Okay, so that is it for this video. Okay, please rewatch, pause, and please ask questions if you have them. All right, everybody, have a great day.